Let me give you two sets, x and y. There. Let's now define a function f from x to y. And what is function f? There, you see it. F of x equals x squared. So how do we show the mapping? Like this. Here we can see that the distinct elements of x have distinct images in y. Such types of functions are called 1-1 or injective functions. So this implies that the function f of x equals x squared is a 1-1 function or an injective function. Now let's again look at the mapping. We can observe one more thing. There is no element in set y that is not an image of an element in set x, right? Such types of functions are called onto functions. And how do you define an onto function? A function f from x to y is defined as onto or surjective if every element of y is the image of some element of x under f. So this implies that this function is an onto function or a surjective function. Now this function was also 1-1. It's also onto. Such functions are called 1-1 onto functions or bijective functions. This means that this is a bijective function. Now let's turn our attention to sets x and y once more. Let's forget the mapping for an instant. Observe set x. Observe its elements. Let me now add the negative of the elements of x in the set x. There. The function still remains the same. F of x equals x squared. What happens now to the mapping? We can do it like this. Now in this case, two elements of set x have one image in set y, right? Such types of functions are called many-one functions. We can also say that if distinct elements in x do not have distinct images in y, then the function is said to be a many-one function. This is one such example. Now observe the elements of set y. Yes, you guessed it right. This still remains an onto function. So now we have a many-one onto function. So now we know about terms like 1-1, onto, 1-1 onto, many-one and many-one onto. So now let's move ahead. Let's forget these sets and this function. Let me give you two new sets. There. We have set x, we have set y. Let me now define a function f from x to y such that f of x equals mod x. How do you do the mapping now? Yes, we do it like this. What can you now say about this function? For one, this is a many-one function. That much is clear. But look at the elements -3, -2 and -1 in the set y. They are not the image of any of the elements in x. So this means that this function is not onto. So we knew what onto functions were like. We now also know what types of functions are not onto. Not too difficult, I hope.